What's up, team? Video for this lesson, new. I'm wearing a hat and a jacket because it's 63 degrees in this room. But let's get to it. That's my explanation. We're talking about the extreme value theorem. Overall maxes and mins. Overall maxes and mins. Now, most of your questions that we will need to concern ourselves with involve something being furthest right or left. Because we're talking about motion and position. This lesson is very much an extension of the previous lesson, okay? How displacements can tell you how far you've gone to the right or to the left, or how much your positions increase or decrease. Now, when we say furthest right, we immediately translate that to a max position. Okay? It's like we're finding an overall max F. The problem is like if you're looking at a graph, might not have an overall max and min if you look at the entire graph. So what will happen is that we will be given an interval. And when we're given an interval, what we realize is a max and a min could occur at an endpoint or when a derivative is 0. Okay? So maxes, mins could occur at endpoints. Really, when do maxes and mins occur? When a derivative, so when it's an x prime, when it's a v, when it's an f prime, when a derivative could be v prime, when a derivative changes sign, let's go ahead with 2 sign changes. So that's when a derivative is 0, or it could be an endpoint. If we have a start and an end, this is a max, but this could also be like an overall max. It's an endpoint. Since my position increases, decreases, increases, I might end up higher than right here. This is a min, but this could also be the min. Do we always need to check endpoints to find extreme values? Not always. Like, for example, if my derivative is positive and negative, I know this has to be the overall max. If you go up and down, your endpoints aren't going to be your maxes. Okay, so it all depends on the situation. Now, I'll tell you right now, the most important problems are probably your calculator problems. Calculator problems. So if you are going to pay more attention about anything, go to these calculator problems and do these, okay? I am going to first start without a calculator. And what you're going to realize is you know this stuff already. You've done this. Furthest right, furthest left. Max or min position. You already know how to find a max or a min of something. You take the derivative of that something and you set it equal to 0. You do a sign analysis of said derivative. But now we have a beginning and an ending. So we have to pay attention to that beginning and ending. Now, the derivative, my velocity, derivative position, is going to be negative than positive. Or positive and negative. Okay? Now that tells me my position decreases then increases. Great. I know t equals 3 must be my min. Must be when I'm furthest left. Now, since we don't have a calculator, I'm probably not going to add the extra step of looking at the area under. I'm not going to have to do that. Since you don't have a calculator, the best thing you can do is really just compare your positions. Like, what is your position at 1? What is your position at 3? And what is your position at 4? Maxes and mins could occur when a derivative is 0 or an endpoint. So I'm kind of skipping this part. in the more important problems, we can't skip it. Okay, when you're given the graph of v and you can't find x, we're gonna need that part. But here, since I have a position function, we can just compare our positions. I know t equals 3 is the min. I can find that position at time 3. 9 minus 18 is negative 9 plus 2 is negative 7. But I can also compare, and this is how I'm going to find my furthest max. This is going to be my furthest right. This is going to be my max. One of these two endpoints. I could either start more to the right than I end, or vice versa. My position at time 1 is negative 3, 1 minus 5 plus 2. My position at time 4 is 16 minus 24, which is negative 8 plus 2, which is negative 6. There's my max, negative 3. I start somewhere at negative 3. I go to the left. I can kind of tell how much I go to the left here if I wanted to. I go to the left 4. I then go to the right 3. Let me just double check that. 1 minus 6 is negative 5, plus 2 is negative 3. 16 minus 24 is negative 8, negative 6. 9 minus 18 is negative 9, plus 2 is negative 7. Yeah. Okay. You could graph this if you wanted to and see, yes, there's the max and the min. This is not something we'll ever be able to do. Graph something and look at when it's a max or min. We might look at a max or min to answer a different question, but you're never answering a question, when do you have a max or min, by looking at the graph and looking at when it's max or min. All right. All we're doing is just practicing taking derivatives and setting them equal to 0. Okay. This is all like first semester stuff. T squared equals 4/3. T equals 2 over root 3. Just leave it like that. 0, 2 over root 3, 3. This will be positive. This will be negative. This is my derivative. I'm going to the left and then to the right. This is going to be my min again, and then I compare my endpoints for my max. I'm not going to plug 2 over root 3 into this. I don't want to. It's really asking you when, so t equals 1 is when I have a max, t equals 3 is when I have a min. X of 0 is 0. X of 3 is 27 minus 12, which is 15. There's my max. So this is furthest left, this is furthest right. Okay, more the same again. If you want to just blow through these, blow through these. These are not the important ones. These are not the tricky ones. These are tricky on page 2. The most important ones, page 3. Page 3, page 4. Those are the important ones. Make sure you get to page 3, page 4. Blow through these. These are not as important. There's like one question on your test where you're given a position function. The rest of your questions, you're given a velocity. Okay? So, get to page 3/4 right now. It's the important stuff. But I'm going to keep going. Just practice. This is good practice. Taking derivatives, setting equal to 0. I'm giving you horrible examples because they're all the same. The min's like in the middle. It won't always be the first. Like x of 4, so when t equals 4, I'm going to be furthest left. To figure out furthest right, I have to compare my two positions. Great. 125 minus 150. You might not think it, but You think a position negative 25 would win, but if I plug in 4 cubed minus 6 times 4 squared, I'm not going to do it, but I'll show you it's going to be less than 25. 4 cubed minus 6 times 4 squared is going to be less than 25. Negative 32. See? I know that because of my sign analysis of my derivative. Okay. Again, this is not important. This is good practice. The important questions, the questions that trip people up. Page 3, page 4. Get to those questions. Do it now. Because that's when we have to find displacements. These are easy because you can just like compare actual positions by just plugging it into the position function. The rest of them are not as easy. All right. This is a good example of like, yo, I don't know anything for a fact. I don't know if 2 is for sure the max or 4 is for sure the min. This was for sure the min. So we only had one candidate because the derivative only changed signs once. But here we'll have 2 candidates. Like x of 2 could be the furthest right, but also x of 5 could be the furthest right because my position's increasing before 2 and increasing before 5. Furthest left, my 2 candidates are x of 0 and x of 4. Unfortunately, I have to find those positions. Again, this is not a problem I would be asking you on a test where you'd have to do this type of calculations. So like again, page 3, page 4, most important ones. Page 2, good questions. I hope, like, go ahead and skip this. You don't have to do the rest of it. I'm going to show the answer in case somebody's checking it. 0, 0, that's easy. So that's where I start. So we can find my displacements. Like again, if you like find the change in your positions, you could find your displacements if you wanted to. Now that we have a calculator, it's like doable, but like whatever. Let's just set it up so I can just change the numbers. 1/3, 2 cubed. Again, I would not ask you this question for a quiz or a test because I would not expect you to do these calculations without a calculator. This is just so you know. All right, 6 2/3. That could be furthest right. Let's go to 4. Five and 1/3. That makes sense. Why does it make sense? I start at 0. I increase my position to 6.667. So this is plus 6.667. If I talked about the area under my velocity, we would find that. Then I'm subtracting like 1 1/2. 1 1/3. Then I will increase 1 1/3. This is a horrible question, guys. Like, there's 2 locations where you're furthest right. This is when you're furthest left. Okay, horrible question. Hope you skipped it. Okay, these are good. Maybe not worth having 4 examples of, but it's just like a good question because a lot of people would get tripped up on this. One is your velocity at a max or a min. A lot of times, when people are asked to find a max or min, they always think about the first derivative is what they need to do, okay? And they're like, okay, here's my velocity. I need to figure out whether this is a max or min. But it's very important to realize, like, yo, something is a max or a min. V is going to be a max or a min when its derivative equals 0. So I actually have to look at a second derivative to find when a first derivative is at a max or min. So you're here, you're going to blow past this and go straight to here. Now this is great because we have a situation where, yes, my velocity's derivative, my acceleration is just positive. This tripped up a couple students on a quiz. They're like, what do I put here? It's 2. It's like, yeah, it's positive 2. It's increasing at 2 meters per second. We're going from 1 to 4. This is great. This is telling you your velocity is increasing consistently from 1 to 4. What do you know? Your velocity at time 1 must be the min. It's when you are going, I guess, like with the least, the min velocity, and this would be the max velocity. Now the question's like fastest to the left or fastest to the right. It might not necessarily get you the correct answers, but let's see. Again, I'm comparing my velocities. Again, this is a secondary important question compared to the questions on the next page. So good, it's a good one, a good no calculator question. If you need to find the max of something, take its derivative and set it equal to 0. That's the key to this page. But then go on to the next page and focus on that, okay? That's the max. So this would make sense. This is when I'm going fastest to the left and the velocity's min. This is when I'm going fastest to the right. Won't always be that case. So again, first derivative will tell us when x has a max or min, but the second derivative will tell us when v has a max or min, its derivative, v prime, a. So again, it's a funky one where it's just positive. I really focused on that third page again, guys. V prime tells you about v. V of 0 is definitely going to be the min. V of 0 is -4. So yeah, I'm moving to the left there. And then v of 3, the last time, v of 3 is 27 minus 4, which is 23. Again, you could skip these two. Honestly, it's fine. I won't judge you if you skip these two. Go to the next page. Those are the important questions. This is just good practice. Understanding for v's max and min, you need v's derivative. There we go. V's derivative tells you about v. V is decreasing then increasing from 0 to 5. V of 2 is going to be the minimum v. The minimum v will be when I plug 2 in here. (12 minus 24 is -12. The max v will either be at 0, which is 0, or at 5. I have a feeling it's going to be 5. 25, 75 minus 60, 15. Right? Yeah. So, min v, max v is 15. This is a candidate that lost. Again, good practice. How do you find the max v? You need v's derivative, but like we're going to blow past this to the most important questions, which are coming up on the next page. Zero and 5 are going to be the maxes. 3 is going to be the min. Yeah, skip it. Skip it. I'm not doing it. I'm not doing it. Okay? I don't want to plug in 3 into that. I'm not going to do it. So let's go to the important questions. Okay, here we go. This is it, guys. You're given a velocity. Okay? You're given the derivative. All the other ones you're given a position. That's easy. You can just plug in values to compare positions, right? But now you're given a velocity. Or you're given a graph of velocity. This is where your understanding of lesson 2 is crucial. Okay? you're given a velocity and initial position over a time frame. Let me just show you the first example so you know what's going on. What's the important thing for all of these problems is the analysis of your derivative, the analysis of your velocity. Zero to 8, zoom fit. I have a feeling it's not going to be pretty. Okay, starts at 0. We have negative velocity, positive velocity. Please don't change 3 times. Negative velocity. That's good. All right, good. Fine. 2 sign changes are not that bad. All right. Here's your velocity. Your velocity being the derivative position. It's negative until this value A. It's positive until this value B. It's negative all the way to 8. Cool. My position is decreasing, then increasing, then decreasing. Great. My position at time 0 was 3. Great. I don't know any of my other positions right now because I can't take the antiderivative of this and then find C and then just start plugging in A, then B, then A. This is where the most important thing of this unit comes into play, where the area under your derivative, the area under your velocity, this area here tells me how much I went down. This area here tells me how much I've gone up. This area here tells me how much I've gone down. Combining these numbers with a position that's known will tell me what is my position at time A, what is my position at time B, what is my position at 8, okay? And we know for a fact that this could be a min, this could be a min. Why? It's when our derivative changes sign from negatives to positives. It's a relative min location, and then this endpoint, because my derivative is negative beforehand, it's like I go down, then up, then down. A or 8 is a min, versus 0 and B could be the max. Now we have to do a little bit of legwork. It's a lot of legwork, but like you should understand what to do. Once you've done it a couple times, it makes sense to you. We need to figure out what is A, what is B. We need to figure out all these displacements, and we need to compare our positions. It's more work than just plugging it back into X, but we don't have X, so we have to do this. We have to find the area under V to find the displacement of X. So here we go. We should always have Y equals 0 graphed in the background. You don't see it, but it's there. There's a 0 there. Now, if you found the first 0 and you went all the way over here to the left, it's probably going to give you a funky number that you're going to be confused by. Make sure you understand that that's your calculator telling you it's at 0. Just if you're worried about it. Enter, enter, enter. It might just go straight to that one. Yeah, like if you plug in 0, you get 0 to the 2/3, it's 0. So like remember, like you can look at that, or you can look at plugging in 0, you get 0. I think it's the problem is I didn't graph the window to the left, so we don't know what's happening to the left. So that's why the calculator didn't find the first 0. But now let's find the other two, A and B, and we're going to write them down. A is 2.712389. I'm going to store that. That way I can use it easily. X is found when you find an intersection. Store that as A. Bam. Now let's go find B. This is a process you will have to practice. It is not that bad, but you have to be able to do it. B is 5.8539816. My cursor disappeared. There it is. B is 5.8539816. Okay, store that as B. It's stored as X now. If you type in X first, Bam, that's that new number. Store that as B, that way we can use it. Now let's just do a little bit of work, okay? Let's do a little bit of work and find these numbers, find these displacements. It's not going to be that bad. If we know you do your velocity times your times, you'll find your displacement, how far you traveled. Let's break out Math 9. This is a lot easier to do in the home screen because you can use the numbers you found. And let's go 0 to A to B, and B to 8. T to the 2/3. Is it a lot of work? You know, yes. Once you get the hang of it, though, no big deal. When you understand why we're doing this, should be no big deal. All right. Start out. I go down. These numbers should make sense. Positions decreasing by this much. If you want to go ahead and tell me what x of a is, you could. I'm just going to keep going, and then I'll use those numbers at the end. Let's go A to B, and then B to 8. $5.259. Okay, just know what that number is, and then B to 8. This is annoying that there's so many things to check. If there's only one sign change, you should be like hip hip hooray. When there's two sign changes, you should be like, oh, annoying. Ooh, negative 5.729. This should make sense in the graph if you look at the graph. Look at the areas. This is a small negative. This is a large positive. This looks to be a larger negative. Okay, small negative, larger positive. Okay. This should make sense the next part. If you know your displacements, you'll find all your positions. Once you compare all your positions, boom, you have your candidates listed out. Compare your positions, you're good. So we get 3 as my starting position. I decrease by 2. 0.9229. Now, I increase 5.259 to get to my position at time B. So I start here, and then I increase that 5.299, or 259. Now I get to 6.182. And then finally, I have that position and I decrease by 5. So add that negative 5.729. Boom. 0.453. Okay? It's that simple. Now that we have that, what do we got? Biggest number, max. Smallest number, min. Is that a negative? 0.4 and 0.9? Yeah, winner. This is when we're furthest right. This is when we're furthest left. Now I'll let you in a little secret. This, I think, makes the most sense. Unfortunately, the work that I showed is not work that would be accepted for full credit in terms of justifications. Moving forward, when we prepare for the actual AP test, like I need us to get the right answers, but we need to kind of show how you got these numbers, which means like on the side or on the bottom, you need to be like, yo, x of a was x of 0 plus the integral from 0 to a of v. You just have to write this. X of b equals x of a plus the integral from a to b of v. X of 8 was x of b plus the integral from b to 8. This needs to kind of be just like shown in the background as this is where the numbers come from. For your test coming up, I'm fine with you just like intuitively understanding what's going on. Areas under velocity displacements. Displacements tell us how much we're going up and going down. But moving forward, this needs to be shown so that the people who are grading the AP tests know where you got these numbers from. You didn't just cheat. Got it? Okay. So that's it. Let's keep going. Ooh, this is a fun one because I'm giving you x of 4 is 3. I like my new way of like writing the positions up on the top. I think I'm going to go back and just probably re-record the lesson 2 video and do it this way. I think a lot of times with the dude moving right and to the left just didn't make much sense to people because they confused it with like the derivative analysis. Anyways, I'm just talking. Zoom fit. Hope for one sign change. 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 Oh no. Why do we do this to ourselves, Mr. Messner? Because I'm cool. I don't know why. Let's leave some space. Let's make sure we understand things. 0 to 4. There's an A, there's a B. That B's probably at pi. No, it's not at pi. Because that's after. No, it should be at pi. Sine of pi is 0, right? Oh, but then it's like -5. That makes things complicated. All right, so anyways, that's my v. That's my x prime. V is negative. Again, why do I give like same examples in a row? I'm better than this. Maybe next year I'll change it. Positive, negative. Okay, so positions decreasing, increasing, decreasing. I'm told x of 4 is 3. X of B must be a possible max furthest right. X of A has got to be a possible min furthest left. X of 0 has to be a possible max because I go down, up, down, up, down. And it's all about these areas. This is very comparable to this, so I don't know which one it is. We got to do the work. So again, this is the intense part. We have to find the intersections. We think it's going to be at 2. It's not. That's B. We got to find A. That's A. Oh my gosh, what did I forget to do? Store them. X, store as A. I could just type in and store it as B, but I'm just going to go ahead and do it again so I have the entire value. Enter, enter, enter. Store it. X is now that. Store it as B. We will use those numbers because we need to find the displacements, the area under my derivative. The area under my derivative. Math 9. 0 to A to B, B to 4. Close your parentheses, -5. I wonder if all the other ones have 2 sign changes. If so, I'm sorry. That's cruel. I didn't mean to do that. That's how much we're decreasing, how much my position's changing. I wish I could take the antiderivative and just like plug in 0A and B, but I can't. I'm not going to look at the max and mins of this graph. The max and mins of this graph has nothing to do with the max and mins of my position. They actually have to do with the maxes and mins of my velocity that I'm seeing. Add 9.009, B to 4. Negative 8.148. Okay. I ended at 3. And again, this is, where do you show this work? I'm going to take my position at 4, which is 3, and to find my position at B, I will need to subtract B to 4, subtract the negative. Or you could say, it's tricky, but the right way to do this is like x of B equals x of 4 minus B to 4. Now there's another way to do this where you can switch these numbers and say you're adding it. But again, this is what you'll have to show in the future. For right now, you could just do like 3, and then since I went to the left, I need to come from the right. So I'm subtracting that negative to get 11.148. This should make sense. I have here, I need to subtract 8 to get to there. Okay, so I'm going backwards. I'm doing the opposite. I take that position, and then I'm going to subtract the 9 to get where I came from at A. And then I have that position. I'm going to subtract the negative 0.343 or add the positive 0.343, however you want to do it, to go back in time. So all of these should make sense, 2.483. I start here, subtract 3.4343, add 9.009, subtract 8.148. We can see my max. This is when I'm furthest right. We can see my min. This is when I'm furthest left. Now what's interesting here, like they happen to be at the relative maxes and mins. This one had a endpoint as a min. That's what we're doing. And maybe the work behind it, x of A equals x of B minus A to B of V, x of 0 equals x of A minus 0 to A of V. Okay, it's like going backwards. It's like that whole solving thing that we did. Yo, if there's 2 sign changes, I'm changing the problem. I hope you pay attention. The next 2, I'm only doing 1 sign change, or else it's just like excessive. On your test, one of your questions, you'll be given V, just like this. Both of your calculator questions, you're given V. Okay. One of the questions, it'll change signs once. One of the questions, it'll change signs twice. So you're ready for both. We've just done a couple change size twice. I should zoom fit. This is going to change signs twice. Yeah, I'm switching it to 0 to 6. I'm saying this is x of 6. Sorry about you. Yo, if you actually do these problems, my bad. Most of you don't. Some of you do. Zoom fit too. The next 2 problems, I'm not changing signs twice. Oh man, what do I notice? I definitely go to the left a lot more than I'm going to go to the right. I'm going to go right to a little bit, but then I'm going to go to the left a lot. I think I'm going to end up to the left of where I started. So I know my most left is at the end, and I know my most right has to be at this middle point at A. Why? Because I go to the right, then I go to the left. So if you go to the right, go to the left, like your max is when, yeah, your position changes from increasing to decreasing, and it doesn't do anything else. 2 sign changes, like just excessive sometimes. Needed sometimes, but excessive other times. 0 to 6, A, that's going to be a pi, guaranteed. You might be asked to figure that out by hand. Why? It's like you could set t equal to 0 and sine t equal to 0. You'd be able to find when sine is 0. It's a pi, 2 pi, 3 pi. So like maybe that helps you with your calculations. You don't have to worry about all these decimals and storing. So I'm not going to. My derivative, my velocity is positive than negative. So that means my position is increasing than decreasing. I know x of A has to be my max. Must be, must be, must be. I'm going to have to figure out what that is. I'm given x of 6 is -2. So again, I have to go backwards. So I'm going to have to do x of 6 and then subtract the negative a to 6. We'll talk about how you could add 6 to a. That's going backwards, but like I don't want to confuse you, so I'm not going to do that. We could also say x of 6 equals x of a plus a to 6. If you're going right, that makes sense. Whatever, subtract it, you get the same thing. X of 6 minus. So, Math 9, 0 to pi. Let's find our displacements. T sine t. It's pi. That's funny. Area under my derivative going up. Pi. I would not ask you to find this by hand. A to 6, which is pi to 6. Minus 9.182. X of a, take that -2, subtract the pi to 6. This value should make sense, guys. 7.182 minus 9.182 gives us -2. Make sure this makes sense to you. I have a position. This is my change in my position. I need to add pi to get there, so I'm going to subtract pi from that. 4.040. Add pi to get to that, subtract 9 to get to that. These numbers make sense. What do we have? This is definitely my max. And then my min is actually position of times 6. Won't always be the right endpoint, could be the left endpoint, all depends on the situation. This is when I'm furthest left. This is when I'm furthest right. Okay, again, if there's 2 sign changes, I'm changing it. Let's analyze V. Zero to 3. Big money, no whammies, no whammies. Zoom fit, stop. 1, 1, 1, 1. Yes. All right, perfect. I hope the left endpoint's my min. It's a really similar situation to the previous one. I wish I like flipped things, but whatever. I hope it makes sense. Like these are just examples. I can't cover everything with all the examples. Here's my derivative. Here's my velocity. It is positive until a. I don't know what that value is. It is negative until 3. Did I graph the right window? I feel like I typed in 4. Nope, we're good. My position increases then decreases. X of a has to be the max. How do I find x of a? I do x of 0, which I know, that's nice. X of 0 is -4. So x of 0 plus 0 to a. Okay, and that'll get me x of a, and then x of 3 will be x of a plus a to 3. You could also do like x of 0 plus 0 to 3 as well. But whatever, if you're already doing the work now, it's fine. I don't care. Intersect 2.061. Let's give it some space here. Let's let it breathe a little bit. Okay, don't use a rounded number in an integral. You can round your answers, but in your answers should not be used rounded numbers. Okay, hopefully you got that. Home screen, Math 9. Let's go 0. Oh, store. I keep forgetting to store. Yeah, there you go. Store as A. Boom. Okay. Math 9. 0 to A of t squared cos t plus 2. Okay, area under my derivative from 0 to A is a nice big plus 4.164. That's going to be added to negative 4. To give me 0.164, which is my position at time A. That's my max position. Then I need A to 3. I'll show you one extra thing to do, maybe to check. Negative 3.116, so I actually go up more than I go down. Oh, I think this is exactly what I wanted. The start is going to be the min. That's great. So I got that 0.164. I'm going to add that. I get my position at time 3 is negative 2.952. So we're done. X of A is the max. It's one furthest right. And X of 0 is the min. It's one furthest left. Min and maxes occur when a derivative equals 0 or an endpoint. Here are your candidates. Here's how I found them. Oops. This is 0.164. A was that number. What was that number? 2.0610. All right, cool. Yo, it's the same deal. These are easier, though. Probably should have given you these first. Here's my velocity. It's the derivative of my position. It's positive until 3. It's negative until 5. It's positive from 5 to 6. My position increases, decreases, increases. My position at time 0 is 2, so they gave me that. The area under my velocity tells me how much I'm going up, so that means my position at time 3 is 7. Then how much I'm going down, which means my position at time 5 is 4. And then how much I'm going up, which means my position at time 6 is 7. What are my candidates? Endpoints, zeros of my derivative. This could be the max. This could be the max. They tie. What? What did I say? 7. This is a 5. 2 plus 5 is 7, minus 3 is 4, plus 1 is 5. Silly Mr. Mester. Uh-oh. Uh-oh. There we go. There we go. We're good. We're good. 5. Boom. This is the max x when its derivative is 0 or an endpoint. This is the min x. Furthest left, x of 0 is 2. Furthest right, x of 3 is 7. Fun. Now we know x of 3 is 4. Great. I love my new kind of method. Uh-oh. What's my new method? It's putting those positions at the top. All right, 0. I'm going to 4. Here's my velocity. It's my derivative of my position. It's negative until 1. It's positive until 3. It's negative from 3 to 4. My position decreases, increases, decreases. Honestly, I should have done these problems first and then done the problems with the correct calculator. The area under my derivative, the area under my velocity is how much I'm increasing, how much I'm decreasing. X of 3 is 4. I don't like doing this now. Instead of showing you the guy moving right to the left, it's like, here's the position. He gets to a position of 4. Then just like make sure it makes sense. I go down from left to right, so my position at time 4 has to be 1, possible min. This is a possible max. This will be a possible min. I add 6 to get to 4. Subtract 6 to figure out where you came from. You came from -2. I subtracted 2 to get to -2. Where did I start? At a nice fat 0. So 0 minus 2 plus 6 minus 3. Turns out this is the max when I'm furthest right. And here's my minimum, furthest left. Okay. In the future, we're going to be asked to justify. It's like, when are you furthest right? Justify your answers. All you're going to be like is like, yeah, we get a max or a min when a derivative equals 0 an endpoint, and compare all the candidates. If you're quick about finding them, it's no big deal. This would not be accepted for your work, though. You'd have to do like x of 3 is 4. X of 4 equals x of 3 plus integral from 3 to 4 of v. Why did I put 7? 3 to 4 of v. I won't care about this right now. X of 1 equals x of 3 minus the integral from 1 to 3 of v. X of 0 equals x of 1 minus the integral from 0 to 1 of v. Or plus 1 to 0, but don't worry about that. All right. Free response. This is good stuff. There's only 2 questions. These are the questions that you need to practice for your test, the free response questions. Don't get intimidated by it. Your review is all free response. So here we go. Particle moves along the x-axis. This is velocity. This is velocity. Fantastic. Yo, we just start out. I can do better. We just start out. Bam! With a velocity, which is a derivative sign analysis. Negative until 3, positive from 3 to 5, negative until 6. We're talking about an interval from 0 to 6. Velocity 0 at 0, 3, and 5. Cool. Graph has horizontal tangents at 1 and 4. Okay, good. So we could do a v prime sign analysis. V decreasing, increasing, decreasing. Maybe we'll have to do that. The areas are 8, 3, and 2. Now this is where a lot of calculus teachers don't like to say area being negative. Like they think of area as being a positive. They think of accumulation as being negative. If you accumulate your negative velocities, you'll have a negative displacement. All I'm saying is like, be careful. We're going to list that as -8. That's 3. We're going to list that as -2. Because you know it's like your velocity is negative, your position must be decreasing. This is how much your position is decreasing. You're not going to say you're adding 8 because your area is 8. You say you're decreasing 8. This is how much your position is increasing. This is how much your position is decreasing. Great. At time 0, the particle's at position of -2. Now be careful how they're listing this. This is x of 0 equals -2. So I'll put that as my starting. X of 0 equals -2. If you want to just go ahead and be like, ba-bam, ba-bam, ba-bam. X of 3 is -10. x of 5 is negative 7. X of 6 is 5. Negative 2 minus 8 plus 3. That's a negative 7 minus 2. That should be negative 9. My bad. Okay. Okay. Find both the time and position of the particle and the particle's farthest to the left. Justify your answer. All right, here's my answer for part A. Farthest left when x of t is a min. Mins when a derivative equals 0 or an endpoint. X of 0 equals negative 2. X of 3 equals x of 0 plus 0 to 3 of v, which is negative 10. X of 5, I could skip. I know it's a max, but whatever. X of 3 plus 3 to 5 of v, and that's negative 7. X of 6 equals x of 5 plus 5 to 6 of v, and that's negative 9. Furthest left, it's min. So like circle this. Yeah, cool. You start at position negative 2, subtract a negative 10, add 3 negative 7, subtract 2. Here are all your candidates. You compare them all. You justify how you got all the answers to them, and you're good. How many values is the particle negative 8? This is great. You don't see negative 8 here. You got negative 2, negative 10, negative 7, negative 9. If you list off all 4 of those, though, you realize, like, at some time between 0 and 3, you're going to have to pass through negative 8 there. So somewhere between 0 and 3, somewhere between 3 and 5, since your velocity is positive, you're going to have to pass through negative 8. And then somewhere between 5 and 6. Why? It's like you got to go from negative 2 to negative 10, negative 10 to negative 7, negative 7 to negative 9. And since your signs are consistent, you decrease from negative 2 past negative 8 to negative 10. This is the intermediate value theorem we're kind of saying. Since function is continuous, since the velocity is negative, you're going to have one time between 0 and 3, one time between 3 and 5, one time between 5 and 6 because of that. Don't worry about the justifications. If you just said like t equals 3 or 3 times, say like your velocity is consistent between 0, 3, 3 and 5, 5 and 6 in terms of its signs. Therefore, you must cross through negative 8 somewhere between 0 and 3, 3 and 5, 5 and 6. Boom, you're good. Honestly, for your test, just say 3 times. You'll be fine. We'll worry about justifications later. Let's just get the right answer. From 2 to 3 is the speed of the particle increasing or decreasing. 2 ways you can answer this. You can either reference the signs. V prime signs, or V is decreasing until 1. It's increasing until 4. Decreasing after 4, or V prime signs are negative, positive, negative. Between 2 and 3, velocity is negative, but acceleration's positive. You could say, oh, signs of V and A are opposite. You could say your velocity values are negative and increasing. That works. You could say your velocity values are getting closer to 0. That works. Whatever you want, velocity speed is decreasing. VA opposite signs works. That's a good reason. These values are getting closer to 0. I believe that'll be consistent. V is negative and increasing. Maybe say like V values are closer to 0, trending to 0, they're negative and increasing, that works. When's the acceleration of the particle negative? A is negative when V prime is negative or when V is decreasing. Any of these would work. You don't have to write all 3. Just write one of the 3 as a good justification. you'd go 0 to 1 and 4 to 6. That's a free response question. 9 out of 9s, all over the place from you guys, okay? From everybody, it should be 9 out of 9. This is it. This is it. Last question. This is not that long of a homework. Because what was important? The displacement, the fundamental theorem of calculus, areas under derivatives, changes in totals, like displacements, so important. If you understand it, you're good. Okay, another situation, you're given the velocity, different situations, call for different things. It's great. You have a position. Oh, this is good. They tell you we're on the y-axis. We've been typically talking about our dude moving to the left and right on an x-axis, but now we're talking about a dude, Spider-Man, who's moving up and down on a y-axis. Nothing changes except for, instead of saying my position is an x, we're going to say our position is a y. So the position at time 0 is a y at 0, which is -1. Don't let it freak out. What should we do for all these? We honestly should start by graphing V. I could do part A without graphing V, but like y? Why when we could just like look at it? This is arctangent. So they don't give me an interval, and that's a little bit interesting, but we probably should see something that happens that's consistent. Your velocity is positive and then negative, and then it just stays negative, okay? Now, let's find T2. V of 2, I could find that by plugging in 2 into V, but watch, guys, this is perfect. We have V. Why don't we just like write down what's going on? My velocity is negative until some point, positive until some point, and then negative after that point. That's my derivative of my position, so my position's increasing and decreasing. My velocity at time 2, you can do trace and type 2. That's me plugging in 2 into my velocity. My velocity at time 2 is negative. What else is happening? V is decreasing. So my velocity is negative and decreasing, which means the values are getting more negative, which means I'm going faster to the left. You could say V and A have the same sign, or you could say A at 2 is negative. What is A of 2? Okay, this is good. V prime of 2 equals A of 2. I need to take the derivative of that and plug in 2. Take the derivative at 2. Negative 0.132. Sorry, that's part A. You can take a derivative. Don't forget, you can take a derivative, second calc, dy dx. You can take a derivative in the home screen, math, and derive. Velocity is negative, acceleration is negative. Here's part B. Velocity is negative and decreasing. Velocity and acceleration have the same sign. Velocity values are trending away from 0. I think all of them are accepted. I don't like the last one, but all that's leading to is you're speeding up. Find the time in which the particle reaches its highest point. They don't ask you to find the position. So it's like they just ask you to find the time. It's obvious, and the justification, the statement's obvious. It's like, particle must have a max at t equals, let's find this, 0. Second calc intersect. 0.443. But why? Always reference a sign of a derivative because v is positive from 0 to 0.443, and then v is negative from 0.443 to infinity. If you reference these signs and then just stop, that's it. You can say since v is positive, my position's increasing until 0.443, and then velocity is negative forever, so position's decreasing, but it's like not necessary. If you reference the signs of your derivatives on justifications, you win. This is more looking for when we're practicing for the free response portion of the actual test. We will work on justifications more. Hopefully you guys can get this value 0.443 and understand why. They don't ask you for the position though at that time. They do ask you for the position at time 2. Now I'll do this 2 different ways. Like let's pretend we ended at 2 and you have y of 0 is -1. I hope you realize that some of the work that we did earlier is not necessary for like a question like this. If you want your position at time 2, you do not need to go and find your position at 0.443 and then find your position at 2. You do not need to go through the whole adding and subtracting, because what you have at your disposal is this, your displacement, your overall change. Taking out the whole understanding of the 0.443, you could figure out how much you've gone up or down from 0 to 2. So, like, let me just show you 2 different ways. Let's break out Math 9. I hope you're like ready, and I don't care, guys. If you like splitting it up, split it up. Split it up as much as you want. I don't care. It honestly is not going to save you that much time if you're not comfortable with this. Watch. Y of 0 is -1. So again, this is a y, not an x. Y of 0 is -1. I'm going to increase not much. Area under my derivative, 0.046. I increase like a little bit. And then from a to 2, if you wanted to do this, you could do this. I'll show you like why this is totally not necessary. I hope you understand that it's not necessary. We're going to get the same answer. I'm going to show you 2 different ways, just so you understand. Down -0.407. You can take your -1, add the 0.046. That's your position at your max. And then add or subtract the -0.407. And you get y of 2 is -1.360. Okay, cool. That was splitting it up into going to the right, going to the left. This will find just your change in your position. You could just do it this way and say you started at -1. Your displacement from 0 to 2 was 0.3606. I guarantee you it's going to be 0.3606. I know where we're going to end. 0.3606. Take that displacement, add it to -1, and I got that same answer, -1.3606. So split it up, don't split it up. It should make sense. Split up should probably make the most sense. But then understand your calculator can just like add up all of the rights and lefts and combine them into one displacement, one change in position. is the particle moving towards or away from the origin? At t equals 2, justify your answer. Okay, well, I'm below the origin. Like, this is when we might need to think about. Here is the origin. This is a position. Again, it's on the y-axis, so maybe we need to flip it. Here is the origin. It is a position of 0. This is a position. My position is at negative 1.360, so this is where my dude is located. My velocity at time 2, we know is negative. You can see it, trace 2. You can say v of 2 is negative. Since v of 2 is negative, my position is decreasing. We're starting at a negative position that's getting more negative, or we're moving down, or it's like, if you thought about it in terms of the x-axis, you start at a position to the left, and since your velocity is negative, you're moving to the left. So combine this with just a sign, and you can say away. Okay? That's it. Again, I over-explained it. What's the most important stuff? This page and this page and these 2 pages. This is also important, okay? But it's not as important. We know how to take derivative and set it equal to 0 and like do a sign analysis. This was a good page because it's like, don't get tricked. Velocity is a max or min when the sign of velocity is derivative. You might have to go to a second derivative, okay? But hopefully we spent less time on 1 and 2 and more time on 3 and your understanding of 3, 4, your understanding of 4, et cetera, okay? All right. Mr. Mestre out.